In this session, we'll see how to find the resultant of coplanar concurrent forces using analytical method. Now, when there are n number of forces acting upon a body, let's say the forces be F1, F2, another one is F3, and so on. Now we have to find the resultant of these forces using analytical method. We already saw how to do it using graphical method, but in this one we will see how to do it using the analytical method. Now, given a force, and these are the rectangular axis or the perpendicular axis, and we saw how to find the components of the force along x and y axis. So this, if it is F, this is, and this is theta, it is F cos theta, and this is F sin theta. Now, for a given force, we know how to find the components. Since there are so many forces, what we have to do is find out the components of all the given forces in this manner. F stands for the magnitude of the force, where theta is the inclination of the force, always with respect to x-axis. Then the x component will be F cos theta and y component will be F sin theta. Since forces are vectors, they are not scalars, you cannot just add up the forces. All you have to do here is consider the direction of the forces. Since forces are vectors, they not only have magnitude but also direction. Because of this direction, we have to use a sign convention whenever we are trying to find the resultant of a system of coplanar concurrent forces. If we are finding out the components of only one force, we may not follow this sign convention. But when we try to find the resultant of so many forces, we have to use the sign convention, otherwise we cannot add up the forces. Now, what do we mean by the sign convention? Let's have these axes, that is perpendicular axis. We call this as x-axis, and you know that this direction is positive direction of x, and this one points in the negative direction of x, and this one is y-axis and it points in the positive direction of y-axis, and this one points in the negative direction of y-axis. Now, if you try to recollect what you would have studied in school level maths, this one we call as the first quadrant, and this one as the second quadrant, and this as the third quadrant, and this as the fourth quadrant. And let's assume that all these forces are concurrent at the origin. Now, let's try to represent each and every force. Say, this F1, let's assume that it is lying in first quadrant, and let this angle be theta 1. Then what are its x component, y component? All I have to do is project this force or draw lines parallel to y-axis and x-axis. Wherever they meet the respective axis, you will get x component of 1, F1, and this will be the y component of F1. And both these components, if you will notice that they point along, this F1x is pointing along positive x-axis, and this one is pointing along positive y-axis. So both the components are plus in the first quadrant. If the force is lying in the first quadrant, both these components will happen to be positive in nature. Now let's consider another force. Okay, say this is F2, but it is lying in the second quadrant, and let this angle be theta 2. Always inclination with respect to x-axis. Even if some other angle is given, it will be always good to take the acute angle of the inclination of the force with respect to x-axis. We have to find the components of this force along x and y-axis. How do we do that? Draw lines parallel to y-axis and x-axis. Now wherever they are going to meet, that will give us the x and y components of the force. So it is meeting here means this will give me the y component of F2, F2y, and this will give me the x component of the second force, F2x. And how do you arrive at F2x and F2y? So let's make a table here. F1, F2, F3, let's say F4. And each is making an inclination. This is force. This is the inclination of the force with respect to x-axis. Let's say it is theta 1. Here it is theta 2. And we'll write the remaining ones. X component. And this is the y component of the force. Here F1x is the x component. How much is that? It is nothing but F1 cos theta 1. And y component is F1y. How much is that? F1 sin theta 1. And when you come here, x component is F2x. And how much is that value? F2 cos theta 2. And this is F2y, which is equal to F2 sin theta 2. Now if you look up at the direction in which the components are pointing, F2x is pointing along negative x-axis, whereas F2y is pointing along positive y-axis. So in the second quadrant, x component will be negative and y component will be positive. So here we have to put a negative sign here, and F2y will remain positive. Let's assume a third force which is directed in this direction. Say this is F3 and it is making an inclination theta 3 with respect to x-axis. Now again we have to find the components of this force. How do we do that? Draw lines parallel to y-axis and x-axis. Wherever they meet, that will give us the x and y components. So this happens to be the x component of this force 3. So this one will be F3x and this one will happen to be F3y. And how much is that? F3x is adjacent to this angle, so it will be F3 cos theta 3. This angle is theta 3. F3x is equal to F3 cos theta 3, and this will be F3y and it will be F3 sin theta 3. And looking at the sign convention, if you will notice that x component is pointing along negative x-axis and y component is pointing along negative y-axis. As a result, both the components will be negative in the third quadrant. So you have to put a negative sign here, negative sign here. And finally F4, let's say that is lying in the fourth quadrant. some force, we do not know the magnitude, just it is F4, and let its inclination with respect to x-axis be theta 4. Again we can find the components of this force, draw lines parallel to x and y axis. Wherever they meet, that will give me the components of the force. So this will happen to be the x component of the force, F4x, and this is same as this, and this will give me the y component of the fourth force. Adjacent side to the angle is cos, so F4x, here inclination is theta 4, F4x is equal to, F4, it will be cos theta 4, and F4y is equal to F4 sin theta 4. And looking at the direction of the components, the x component is pointing along positive x-axis, whereas y component is pointing along negative y-axis. So in this quadrant, x component is positive, y component is negative. Now these ones you have to remember. In the first quadrant, plus plus, second quadrant, minus and plus, whereas here minus and minus, here plus and minus. So here x component will be positive, whereas y component will be negative. Now how to find the resultant once you have found out the components of all the given four forces? All you have to do is just add up all these x components. That means take the summation of this. In the similar manner, take the summation here. Now the resultant will have, let's say R is the resultant of these four forces. It's having a resultant R. Now this will have two components along x and y axis, which we call as Rx and Ry. This Rx is equal to summation of the x components of all the forces considering this sign convention. So it will be Fxi. In the similar manner, the y component of the resultant is equal to sigma Fi I. These summations we can obtain from here. Sum up all the y components, that will give me the y component of the resultant force. Now if I want to find the magnitude of the resultant, all I have to do is R is equal to square root of Rx squared plus Ry squared, or in other words, it is square root of sigma Fxi whole squared plus sigma Fyi whole squared. This will give me the magnitude of the resultant force. Now I have to find not only the magnitude but also the direction of this resultant force. Here we are assuming this force to be lying in the first quadrant, but once you calculate, it may lie in second quadrant or third quadrant or fourth quadrant. That we have to find out in which quadrant the resultant of all these forces lie. Now we have to find the inclination of the resultant with respect to x-axis. Let's say that is alpha. Alpha is given as tan inverse of sigma Fi, where sigma Fi is summation of all the y components of the given forces divided by sigma Fxi. Now while summing it up, since we are having some are positive, some are negative, here also some are positive, some are negative, the summations may be positive or negative. For that reason, you have to take the absolute value of these ones. when you arrive at the angle. Then that will give us the angle between 0 to 90 degree, or in other words, it will be an acute angle. This is the way you have to arrive at this. Now, once you arrive at this value, finally you have to find in which quadrant the resultant is going to lie. It may lie here or here or here. How do we determine in which quadrant it is going to lie? That depends upon the sign of this and sign of this sigma. Okay, suppose this is positive, the entire summation is positive, then because of this condition, the resultant is going to lie in this quadrant. In case the summation of all these x component is going to be negative, whereas the summation of y component is going to be positive, then in that case, due to this condition, the resultant will lie in this quadrant. Once you calculate only, you can specify in which quadrant it is going to lie. Suppose this component total happens to be negative, this also happens to be negative. In that case, the resultant is going to lie in the third quadrant because of this condition. In case if the x component is positive and this one happens to be negative, then it will lie in the fourth quadrant. Whereas while taking the angle alpha, we always take the absolute value, and once you get the angle alpha, which will always be the inclination of the resultant with respect to x-axis, once you arrive at that value, depending upon these signs, you can locate in which quadrant the resultant is going to lie.